Today we're going to be learning about inverse trig functions. The idea is that we are going to be given the trig ratio this time, and now we need to find its angle. However, we also need to make sure that it matches up with some certain restrictions, and we'll take a look at that today in class. Let's take a look at the first example here, where we see cosine of x equals negative half. If we want to find the angle in degrees, keep in mind that this is basically asking the question, what angle gives cosine equal to negative half? So the idea here is, if we think about it in terms of our four quadrants, we know that cosine is going to be negative in quadrants 2 and 3. We also know that cosine gives us a value of half when we have a reference angle of 60 degrees. So it just goes to show that if we're in angle, or in quadrant 2, then the 60 degree reference angle will relate to a 120 degree angle, and if we're in quadrant 3, that will relate to a 240 degree angle. But also keep in mind that we can go around the unit circle coterminally, so if we add 360 degrees to each of these different scenarios, we'll end up with the same result. So we need to make sure we add plus 360n, where n is an integer. Okay. We can also do the same thing for problem number 2, where it says sine of x equals negative root 2 over 2. Just erase this here. And so we know that sine is a negative value if we are in quadrant 3 and in quadrant 4. We also know that sine gives us a value of root 2 over 2 when we have a reference angle of pi over 4. Keep in mind we're looking for our angle in radians now. So if we want a reference angle of pi over 4, in order for that to occur in quadrant 3, that must mean we have an angle measure of 5 pi over 4. If we are in quadrant 4, that must mean that we have an angle of 7 pi over 4. And just like problem number 1, because you can go around coterminally, that means that we need to make sure we add an entire revolution, which is 2 pi, and n number of those. So we add 2 pi n to each of those. If you want to check your work, we can use a calculator to see if this is actually holding up. So let's go to our calculator. And let's try our first one where we said cosine of x is negative half. So the way that we can find the angle measure is by looking at the cosine button, and above it we see cosine to the negative first power. That's our inverse trig function. So if we do second cosine, and then we're going to enter in that negative half that we're looking for, that trig ratio. And when we do that, make sure you're in the right mode. You're in degree mode here. So when you actually push enter, you'll see you get 120 degrees, which is what we got as one of our answers. Notice how we don't get the other answer of 240 degrees. We'll look into why that's happening in just a moment. If we do our second example of the inverse sine, we can do second sine so that we get the sine inverse there. And we're going to do the same thing. We're going to enter in negative root 2 divided by 2. And here we get negative 45 degrees. That's weird. In our answer, we got 5 pi over 4. 5 pi over 4, or rather 7 pi over 4, is placing us here in quadrant 4. However, the answer that the calculator is giving us is negative 45 degrees, which is basically saying let's go back. So again, we'll just dissect why we're getting different answers as opposed to what we had solved here algebraically. Okay? So basically, what we're doing here is we're finding what we call the arc trig function. Another name for the word arc is inverse trig function. So when we say something like arc sine, what we're looking for is we're looking for the angle, basically. This gives the angle. Okay? And so let's take a look at why we're getting different answers as opposed to what we solved algebraically. when we look at the trig function, what we had graphed before was we know that the sine graph starts at 0 and it looks something like this, like that. And so because we're looking for the inverse trig function, to find an inverse, keep in mind what we need to have. The question that we're being asked is, does it have an inverse? If it has an inverse, we need to make sure it is 1 to 1, which means it must pass the horizontal line test. If it doesn't have an inverse, then we need to restrict the domain so it does. So if we try to restrict the domain, we always need to make sure that we include quadrant 1, because that's where we're starting from when we have the 0 radian or 0 degree measure. So if we make sure we pass the horizontal line test, here we pass it, here we pass it, here we pass it, here we pass it, but once we reach this point, you'll notice that the horizontal line test does not work anymore. So therefore at this point is where you need to restrict the domain. Now we started at 0 and we made our way to the right along quadrant 1, and this is where we see it actually works with the horizontal line test. If we go backwards, we see we are still passing the horizontal line test up until we reach this point right here. So we need to cut it off here as well. Well, if you think about where those values lie, you're basically within quadrant 1, and also back here, which ends up becoming quadrant 4. So we need to restrict our domain between quadrant 1 and quadrant 4. If you think about our unit circle, quadrant 1 and quadrant 4 is occurring between pi over 2 and 3 pi over 2. Or rather than saying 3 pi over 2, if you work your way back, that's like saying negative pi over 2. Okay, so we're actually going to have to restrict our domain to that domain. So the domain that we're going to have is negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. And the range, well, the range stays the same. We're just kept within this area here, up here, the maximum of 1, and also the range down here, which is a minimum of negative 1. So we'll keep it within negative 1 to 1. Okay, so if that's the case, let's see what this inverse sine is going to look like. I'm going to erase some of these notes here so we can leave some room. And let's take a look at our inverse function. Now for each of these inverse functions, these should actually be capital letters. So we're going to say capital letter S, like this. Same thing here with this one. This is going to be capital letter C. Oops. Capital letter C. And then over here, this is going to be capital letter T. Like that. Okay, so if we take a look at the inverse sine, keep in mind that in order for the inverse sine to occur, the domain and range must basically be flipped. Which means if the original domain was negative pi over 2 to pi over 2, and the range was negative 1 to 1, we're going to swap them. So the new domain of our inverse function will be negative 1 for the x values to positive 1, and the range will be negative pi over 2 to pi over 2. Okay, so everything basically gets flipped. So if we take a look at the graph, what this looks like is now the domain is going to have values of 1 and negative 1, and the range will have values of pi over 2 and negative pi over 2. Okay, so if we take a look at our values here, what we saw was on the very extreme, right here, I'll label this in green, right here, this was at a value of pi over 2 and a y value of 1. So if this ordered pair was pi over 2 comma 1, then it goes to show that on the inverse we should have an ordered pair of 1 comma, pi over 2, which is going to be up here. Likewise, if we go over here to this point here, at the very bottom, if it has the point of negative pi over 2, comma, negative 1, then its inverse will then be negative 1, negative pi over 2. If we had the point 0, 0, well, that's just going to map over to 0, 0 as well. And so what we end up having is a graph that its inverse will look like this. You can do the same thing for all the other points in between. You'll see that you'll basically form this kind of curve here. Okay, so we see that the inverse sine graph is restricted to this area here. We're going to do the same thing for cosine now. So for the cosine graph, when we draw this, we know that a cosine graph starts at 0, 1, and then we kind of form that U shape, and we can do the same thing on the other side, like that. Again, what we want to do is see if it actually does have an inverse. For it to have an inverse, remember, it needs to pass the horizontal line test. And as we take a look at this graph, you'll see the horizontal line test is not passing in the same area that the sine graph was. In order to pass the horizontal line test, again, we can start at quadrant 1, or rather start at the 0 degree measure, and as we go, we'll always pass the horizontal line test, and as we keep going, you'll notice right here, that's when we're actually not going to pass the horizontal line test anymore, once we pass this point, because now we're seeing 2 points are giving us the same y value. So we're going to have to restrict our domain so it just stops here. We'll start at the 0 degree measure, and we'll stop right there, which, as it turns out, is the pi value. That's going to be at pi radians. So what we're seeing is that the y equals cosine x has to be restricted to a domain from 0 to pi, and the range value is still the same thing. It's restricted from negative 1 to 1. And you'll notice here that because we stop it at pi, that's going to contain quadrant 1 and also contain quadrant 2. So we're going to contain those two quadrants. So when we do the inverse sine, we can do the same thing, map it over to the other side. If the domain was from 0 to pi, then that must mean that the inverse cosine must have a range from 0 to pi. If it had the original function had a range of negative 1 to 1, that must mean that the domain has a value from negative 1 to 1. So if we graph this, again, let's make the x values now have negative 1 to 1, and now the range is going to go from 0, which is actually just starting along the x-axis, all the way up to pi. And it looks like we're not even going to go into the negative area for the y values. So again, we can map some points out. If we know that we have the point up here, which is at 0, 1, that must mean that its inverse must map over to 1, 0. If we had a point here at pi over 2, and that was pi over 2 comma 0, then pi over 2 comma 0 should map over to 0 comma pi over 2. Where is 0 comma pi over 2? That would be right here. And then we can map another point over here. This is going to be at pi negative 1. So if we have the point pi negative 1, then we should see that that's going to map over to negative 1 pi. So negative 1 pi will be over here. Okay, and just as we see the curve kind of taking shape on our original function, the curve should also kind of have that similar shape. Again, you can find more points and see how they're connecting, but basically you'll form a shape that looks like that. Okay, alright, so let's do our last graph, which is the tangent. Okay, So for the tangent graph, as you saw on your homework, the tangent graph will basically look like these, I like to call them like shower curtains, like at a car wash, like this, with the asymptotes kind of holding them in place there. What we see at those is that those asymptotes are occurring at pi over 2, at negative pi over 2, and every iteration of pi after that. Okay, so basically if we want to pass that vertical line test, again, if we start at the 0 radians or 0 degrees, it's always going to pass that horizontal line test, basically as long as you're kept within those two asymptotes from the very beginning. You don't want anything on the outer parts, so we're just going to restrict it basically from a domain of negative pi over 2 to pi over 2. And notice the difference here is that because we do have asymptotes, the domain is not going to have the equal sign in our inequality. The range, as we can see, it just keeps on going up and up and down and down, so the range is actually going from negative infinity to infinity. Okay, so now let's go ahead and graph this, the inverse tangent function. And so the inverse tangent function, we know that its domain is now going to be from negative infinity to infinity. Oops, infinity. And our range is going to be from negative pi over 2 to pi over 2. So on our graph, domain is just going to keep on going. I'm just not going to label that, but the range will just restrict to pi over 2 and negative pi over 2. And because we can't touch those values, we're now going to have horizontal asymptotes rather than the vertical asymptotes. And then from there, just imagine that because it is the inverse, this ends up getting swapped, so you'll now have more of like a sideways curve, or I guess it looks like an S now. Okay. So, as a recap, in terms of all of the inverse trig functions, we have inverse sine, inverse cosine, and inverse tangent. In terms of what's important about those three trig functions, we should keep in mind that in order for us to have the inverse sine, it must be restricted to the domain where it goes from negative pi over 2 to pi over 2. What's important about inverse cosine is that when we looked at the graph, the domain got restricted from 0 to pi. And our last trig function, the inverse tangent, the domain was restricted to negative pi over 2 to pi over 2 non-inclusive, as opposed to sine where it was inclusive. Okay, so this is the three main takeaways for today's lesson. Let's turn the page over and let's take a look at how these are applied.